So now to contrast a bit uh, this idea of decomposition-based design, where you decompose the problem into its component parts and then influence those components in order to change the ground problem. Be that a metaphor or because some people think that this is more a metaphor and a way to uh, do these micro interventions and actually get things done, instead of uh, really thinking that this would linearly change the process. Other people do think that this is an actual causal chain that then is being built. But to contrast that idea, I would like to present a bit about what does complexity have to offer also, given how these decomposition-based techniques have not necessarily performed as well as we would have wanted them to. So first of all, we need to think about the determinants or influences on the behaviors and the problems that we are dealing with. So we have these idiosyncratic responses. So it's a non-ergodic system that we spoke about in the last section of this course. And so all of these determinants, they interact with each other. They interact with behavior, and they interact with any intervention that you want to do. In fact, facets of that intervention. So, for example, whether how it is delivered, by whom, is it personalized to you, or is it just a mass campaign? Are you accounting for people's individual personal context in some way? How do people perceive your message? Do they start enacting those things? Because even if they start doing what you want them to do, they might not continue doing it, and or do it in a way that's not useful, and so forth and so forth. So there's a lot of complexity on the very granular scale. We might also want to consider the destabilization that we spoke about at factor landscapes and tipping points. So I will give an example of that in a short while. And I will also talk about the network effects, as well as these evolutionary parallel processes which have not really been utilized in design of these programs. So just to first go into this destabilization and our friendly neighborhood attractor landscape metaphor. So let's consider a situation where we have a valley here, and we have the system in this state, and it's sort of it's in a very deep attractor, so it stays there and plays nice. So we could the time series of that development could look like this. So there is some wobbling, but it stays at a sort of constant level. And Kurt Lewin, that I mentioned, he has this metaphor for organizational change, where he calls this phase sort of a frozen phase. So it's in one phase, and it doesn't really move a lot. Now, when change starts happening, what might happen is that the system switches to this unfrozen stage, where in the attractor landscape, now that this tipping point, this hill between the two attractors, it's really gone very, very, become very, very not tall. And now this system can move between these two attractors quite freely. So what you might be seeing if you're doing a constant continuous monitoring of a time series, you might start seeing these very erratic fluctuations, and there's an increase in entropy and so unpredictability, and what's also called dynamic complexity. So it, you really can't know what the system is doing. And then the later stage, the system might uh, go to a refrozen stage. So it again sort of stabilizes in this new attractor. And the idea is that when the system, be it an organization or a person or a society, what they what happens when the system gets unfrozen is that it's much more easy to direct the system towards one way or another. So if you would want to push the system towards a particular goal and make sure that it uh, restabilizes into a better attractor than what was before, then you really need to uh, put a lot of effort into doing that during the unfrozen phase. So maybe again, a martial arts analogy would be that when you um, get your opponent off balance somehow, it's much easier to then move them around and control their movements. And here are a few papers discussing these issues. And this first one was, for example, it was kind of cute because we were able to uh, show empirically a process that really fit this description. So when people who were taking part in a weight loss intervention, so when we looked at the time series of their step counts, they had before they radically switched to at least 1 week long periods of less activity. We observed this sort of a momentary unfrozen period when their step counts were really being erratic.